now we're going to focus on linear functions. So we're going to take problems and write equations from them. All right, as dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height h in kilometers, assuming that a linear model is appropriate. So what I'm asking you to do is write the equation of a line.
I bet.
Okay, but you have to know the difference between what variable is x and what variable is y. Okay, did I use x and y here? No, I asked you to use t and h. So I want temperature as a function of height. So the temperature, would that be x or y? The y. Your function is the y. So temperature is the function, so that's my y. So the height is my x. Now if you're going to write an equation of a line, you need 2 points. So we know the ground temperature is 20 degrees Celsius. What is the height if you're on the ground?
0.
And my temperature there was
1.
1T. And at a height of 1 kilometer, the temperature is 10 degrees Celsius. So 1, 10. How do I write an equation from that? Slope. How do we do slope?
Y sub 2
Y sub 2 minus
y sub 1 divided by x sub 2 minus x sub 1. Oh, yay. We should write this
Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Change in y over change in x.
Gosh, we're small. Sorry.
Algebra 1 is coming in handy, y'all.
Oh yeah.
Important stuff.
8 grades ago.
Yeah, great.
All right. So then, what else do we need?
Oh, y intercept.
Y-intercept.
How do we get it?
So y does
X.
x is 0, yeah.
So this one, actually, we already have it. We know the point when x is 0, the y is 20. A lot of times, if you didn't have that, you would just plug it into y equals mx plus b. So you take one of your points, like you could do this one. The y value was 20. Your slope was -10. Your x was 0 plus b. And you get that b equals 20. So usually that's what you did. Just plugged in one of your points with that. So instead of x and y, I'd like you to keep the notation that it said. So I want the temperature as a function of the height. So t, y equals mx plus b, my y is t, my slope is -10. Instead of x, we're using h plus our height of 20.
It's a good idea.
Right? What does the slope represent? Slope is the steepness of a line, right? It's a rate of change. We found it by doing y over x. My y, that was my temperature, so that's degrees Celsius. My x was my height, which was in kilometers. Okay, why is it a negative? What does that mean? Okay, so I could say the temperature decreases 10 degrees Celsius per 1 kilometer. So for every kilometer you go up, the temperature drops 10 degrees. Okay, when I ask you to interpret the slope, I'm looking for 2 things. I expect to see a number there. Okay, so if my slope is 5, I better see a 5 in there somewhere. And I expect to see some units. Okay, so it's decreasing because it's a negative. There are different ways you could state it. You could say, you know, for every kilometer you rise, the temperature drops 10 degrees, or the temperature drops 10 degrees for every kilometer. If it was like 5 over 2, you would say the temperature rises 5 degrees for every 2 kilometers. But I expect you to use those numbers in your description. What is the temperature at a height of 2.5 kilometers? So what do we do?
Just put 2.5 and 40.
Alright, so we go to our equation from part A. Again, 2.5. So we get a negative 5 degrees Celsius.
Is that entire blank box meant for us to work in?
Yes, I was trying to be nice and I put a blank box on this one.
I don't think anyone picked up on that now.
I
I'm gonna use that one for example too.
Oh, aren't you?
I don't want to
I
feel
put
bad.
beansy on it.
Me, I love a turtle.
Sorry.
Squeezed it all.
I felt guilty yesterday because the notes were all squished in, so I gave you extra space, but then forgot to point out that I gave you extra
They
space.
now know.
It's
Corbin,
okay.
you have extra space for it.
Thank you. Always so quick to notice.
Are there questions?
No.
Let's try the next one. So Jason leaves Detroit at 2 p.m. and drives a constant speed. He passes Ann Arbor, 40 miles from Detroit at 2:50 p.m. Express the distance traveled in terms of time elapsed. All right. First, let's figure out what x and y are. Did I tell you what variables to use?
No.
No, so you could use x and y if you want. I think I'm just going to do d for distance and p for time. So which one is my x?
Distance.
It says express distance in terms of. That's like saying as a function of. So the function is always the y. So distance is going to be my y, time will be my x. Now, in general, like, couldn't you write a linear equation either way? Yes, but a lot of times in these problems, I'm telling you how I want it. If I say I want the distance as a function of time, that means the distance has to be the y. So while you might get another equation that would work, it's not the way I asked for it. So just recognizing that the function is your y value. So what would be my points? At 2 p.m. So 2 p.m., that would be like time 0, because that's when we started. And we're where we started. So what's our distance?
0, 0.
0, 0. All right. So the next point, what's my time? It's 2:50, so how much time has elapsed? 50 minutes. And my distance is 40 minutes. Okay, so let's write this equation. So slope y2 minus y1 over x2 minus x1. So we get 4/5 or 0.8. We need our y-intercept, although it's pretty easy here. What is it? Yeah. If you plugged into y equals mx plus b, you just take one of your points. And even if I did this one, my y is 40, my slope is 4/5 times x plus b. And we get b equals 0. So the y-intercept is just 0. So our equation, y, which is distance, equals slope, times x, which I use t. So distance is 4/5. B. Interpret the slope. So when I have to interpret, I go back to this fraction. What is my 4? What variable? Yes, that's my miles, it's my distance. And what's my 5? Minutes. So it's a positive, so how would you write this? Mm-hmm. C. If he goes the same speed, how far will he have driven by 3:15 p.m.? So how much time has passed? We started at 2, so at 3:15. 1 hour and 15 minutes. Now when we set this up, when we did our slope, 40 was in minutes, so let's do our time in minutes. So how many minutes have passed?
75.
Okay, so plug 75 in. And get 60 miles. Is that okay? Why don't you guys at least try to start the next one? As a function of, so
Oh, I
the
didn't
cost
read
is
that.
the function, so
Oh.
the cost is the y. So
I
the
read that
number
back.
of chairs is my x, my cost is the
Oh, I
y.
got that right. Okay.
Don't be right then. I just put it
I didn't
as
even
C
read
for
that,
chairs
I
and
still
then
got it
cost
right.
is money symbol.
Okay, so our 2 points then, 100 chairs cost 2,200. 300 chairs cost 4,800. So slope E. So we get 2,600. Oh my goodness. They're having trouble emptying that dumpster.
Oh, snap. I got it.
And so we get a slope of 13. You guys agree with that part?
Yeah.
Okay. Now to get the y-intercept, plug into y equals mx plus b. So I'll just do my first point here. So my y was 2,200 equals my slope of 13 times my x of 100 plus b. Subtract that over. So y-intercept of 900. So my equation, y, or I use c for cost, equals m, so 13 times my x, which I use the variable m. I've never heard it take this long
I'm
to
pretty sure
compute.
it's
They are.
no, I think they're moving the metal rack
Oh, are they?
over there, which takes a whole lot of tractor bumping and.
Okay. I thought they were emptying the dumpster, because
Oh, no.
that's usually what that
We
sounds
can move the lines real quick and check.
like. Okay, so interpret the slope. So this was like 13 over 1. 13 was what? What did that number represent? The cost
For one check.
and 1 chair. So, each chair costs $13 to produce. Or something along those lines. Interpret the y-intercept. I didn't ask you on that on the other ones. The y-intercept was 900. What does that represent?
When it crosses the y-axis,
Yes. So what's my x in that case?
0.
So when no chairs are produced, my cost is $900. So that's like your startup cost, you know, your equipment or whatever. So you could call those the fixed costs, or you could just say it costs $900 to produce 0 chairs. Or you could call, you know, say the startup cost is $900, the fixed costs are $900. Lots of ways you could state it. You just have to explain it in some way. questions?
Boom, it's the end. Go team calculus.